Hello there, this is Mr. Yuppie Roche and his accomplice Wilson, and welcome to Mr. Roche's Flip Class Math 10 No Frills, No Thrills, Low Budget, Low Tech videos. This is in a series of linear relations. It's part 2, and today we'll be talking about the slope and the slope formula. More specifically, we'll be talking about what the slope of a line is, what the slope formula is, and finally slope is a rate of change. So I'm going to sit Wilson down over here and we'll get started. First of all, slope is just simply the measure of the steepness of a line. So we can have all sorts of lines being steep and not so steep, flat, vertical, and so on. We'll be talking about that right now. I'm going to use this ruler to represent a line. Okay? Not very steep, steeper, steeper, flatter, 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 horizontal, vertical. Let's see if we could equate this to an analogy of skiing. If we came across a hill, coming left to right, and we came across this, we'd have to walk up. Okay? This is a positive slope. Most skiers don't like positive slopes because that means trekking or hiking or boot packing or something like that. Okay, so, but we get more elevation. We're going up. Skiers tend to like go down, especially boarders as well. So they like negative slopes. Okay, so that's a negative slope. That's a steeper slope. Okay, that's a flatter slope. If you come to a part that's like this, you better have some speed or you'll be walking because that's a zero slope. If you come to a slope like this, you better hope it's got a nice soft landing because you're going to be free falling. That's an undefined slope. Okay? Undefined, zero. Negative, positive. Uphill is positive, downhill is negative. Let's look at this slope stuff a bit more. Okay, well, slope can be calculated. Okay, slope of a line on a coordinate plane can be calculated using rise over run. All right. Let's see. We said here that this is a slope of 0. Let's see if it can be calculated to be 0. If you have a line, remember it goes infinitely in both directions, just pick out 2 points. Here's a point and here's a point. Okay? The coordinates of that point are -2, 2. And the coordinates of that point are 1, 2. You'll notice because it did not change height, the y coordinate is exactly the same. The x coordinate, of course, has been changed. So if we use that slope formula, equals rise over run, the rise difference is y minus y, which is 0, over the run difference between here and here is 1, 2, 3. And 0 over 3, of course, is 0. Has a slope of 0. Here, well, let's do this one next. The slope, the rise difference between, say, here and here is 1, 2, 3, 4, 5, 6, 7. And the run difference, there is no run difference, 0. Okay? And anything divided by 0, as you know, is undefined. So that's an undefined slope. Undefined slope. Okay, here on the other hand, we have an upward headed line. So pick 2 points on here. 2 points where the grid crosses nicely. Let's say here. Of course, this is much easier done on grid paper where I can see where the lines intersect the grid nicely. Let's find another spot. Let's say here. Okay, so if I just draw a right triangle, it's hard to draw a right triangle on a horizontal or vertical line, but here it's pretty easy. Draw a right triangle. The rise is this difference. So from here down to here is 1, 2, 3. And the run is from here to here is 1, 2, 3. So the rise over the run is 3 over 3, which is 1. So that is a slope of 1. In other words, for every 1 we go over, we'll go up 1 as well. Okay? If I had a slope of 2, it means for every 1 I go over, I'd go up 2. So that would be a much steeper line. A slope of 3 would be over 1 up 3. A slope of a half would be over 1 up only half, or over 2 and up 1. It'd be a flatter line. Okay, let's look at this one here. Let's find two good points here. Looks like a good intersection there. And a good intersection, let's see, right about. That looks like a good one there. Okay, it looks like it's pretty much straight across. So, a right triangle, by the way, you can go above or below the line. The rise difference here is 1, 2, 3. And the run is 1, 2, 3, 4, 5. Okay, so the slope is 3 over 5. In other words, it's not as steep. Oh, and keep in mind, it's downhill, so it's negative 3 over 5. Or put the negative in front. Slope is negative 3 over 5. Now, you could also keep track of the sign as you go. Every time we move to the right, let's do the up and down first, the rise. If we drop, that's a negative. If we go up, that's a positive. Like here, the rise was up. Here, the rise was down. Okay, so that's a negative 3. And the run was in the right direction, so that's positive. Had we gone in the left direction, that would have been negative. Okay, so you can keep track of the signs as you go, or just worry about the positive values and then figure out the sign afterwards, but just don't forget about that sign. Okay. Now let's talk about the slope formula. Well, you don't see it here. Let's develop it. Okay, so it says here, determine the slope of the line joining points -4, 6 to the point with coordinates 5, -3. Well, we could draw a picture. -4, 1, 2, 3, 4, up 6, 1, 2, 3, 4, 5, 6 is about here. And 5, -3, 1, 2, 3, 4, 5, and 1, 2, 3, about here. And if we join those points up, okay, so we have a line. So I could draw a picture first, and then you draw the right triangle, determine the rise, okay, which is going to be from 6 all the way down to -3, which is 9, and then the run is from -4 all the way up to 5, which is also 9. So the slope is going to be rise over run, which in this case, the rise is a drop of 9, so -9 over a run of 9, which is -1. And remember, you can just go 9 over 9 and then determine, because it's downhill, it's going to be a -1. Okay, now, what if we don't want to draw a picture? What if we just want to use these 2 points? Okay, well, how did I get my rise? I subtracted the y coordinates, right? So this coordinate here was, it was 6 high, and then I subtract -3. 6 minus -3 is 9. Okay, so I subtract my 2 y coordinates. Oops. So my y of 0.2 minus my y of 0.1, or vice versa, it doesn't matter, but be consistent. And then over, how do I get my run? Well, I subtract my x coordinates. So x2 minus x1, or vice versa. But be consistent. If I'm going to go this minus this in the y's, don't switch and go this minus this. Stay the same, and that way your signs will work out properly. So this is the slope formula right there. Make sure you write it down. Now, of course, we could be talking about other things besides x and y, and therefore we might change those letters around, particularly if it was a real-life kind of a situation. Speaking of, let's find some real-life situation. Well, when we talk about slope in real-life situations, we're often talking about a rate of change. So slope as a rate of change. Same basic formula, but since we are finding a rate, units are usually required. You'll notice here I had no units because it was just -9 units downwards and positive 9 units sideways. It's just units over units, or squares over squares. Therefore, the units would cancel out. So it's just a ratio, okay? Rise to run. But when we're dealing with other real-life situations, often the units are different, and so we cannot cancel them off, and they must remain. Okay, so let's see. Here we have an example where we have temperature of something, and time. Okay, time, the temperature seems to depend on how long we've been monitoring the situation, so therefore the time is independent and the temperature is dependent. So we have two readings here. At 2 minutes, it was at 50 degrees, and at 6 minutes, it was at 250 degrees. So if we want to find the rate of change, okay, now the slope here, okay, if we didn't deal with the units, would be all wonky, because you'll notice that this scale is completely different than this scale as far as the increment size, okay? So we are dealing with rate of change, and we're going to keep in mind the units. So let's see, we have slope, or rate of change, okay, think of it one and the same, y2 minus y1 over x2 minus x1. We can call this point 1 and this point 2, or vice versa, just make up your mind, okay? So the coordinates of this point are 2, 50, and the coordinates of this point are 6, 250. So now going back to this formula, let me move this over. 6, 250. Is that point? Okay, so now going to this formula, slope equals 250 minus 50 over 6 minus 2. So now my slope, or my rate of change, is 200 over 4, which equals 50. 50 what? 50 degrees Celsius per minute. That is my rate of change of the heating of that substance. Had it been cooling, let's say we were threw something into a deep freeze or something that's cooling, well then that would have been a negative because it would have been going down. But in this case, the temperature was going up. Okay, so it's a positive rate of change. Okay, our last example, we're going to do without drawing a picture, just using a circle here. Excuse me. A co-pilot determined that 2 minutes after takeoff, the plane was 2,000 feet above sea level. And after 6 minutes, they were at 3,000 feet. Determine the rate of ascent. Okay, so we have two pieces of information. After 2 minutes, it was 2,000 feet. That's an ordered pair. Okay, and again, the height is dependent on how long the plane has been flying. So therefore, the time is the independent variable, and the height is the dependent variable. So we have the first point, let's say, the first point was 2,000. Okay, 2 minutes, 2,000 feet. And the second point was, after 6 minutes, was at 3,000 feet. Okay, so we have two ordered pairs, so now we can use the slope formula. So slope equals y2 minus y1 over x2 minus x1. Now you can see here, I could have also used different variables. Instead of y, which is actually altitude, I might have said a2 minus a1 for altitude, and t2 minus t1 for time. Doesn't matter, it still works. Okay, so m equals 3,000 minus 2,000 over 6 minus 2. This is 1,000 over 4, which is 250. 250 what? Well, I need units because it's a rate. 250 feet per minute is the rate of ascent. Okay? Now we could have done a similar thing in a descent. So then it would have been a negative rate of change because it's coming down. Okay, that's it for my examples for now. If you encounter anything in your book that you are unsure about, that's where you bring questions to class. Okay, thanks for now.